Welcome to the Fox Learn. The C# programming language can be used for many kinds of applications, including websites, desktop applications, games, phone apps, and command line utilities. C# has been center stage for Windows developers for about a decade now, so when Microsoft announced that Windows 8 would introduce a new style of application, optimized for touch-based interaction on tablets, it was no surprise that C# was one of the 4 languages to offer full support from the start for these Metro-style applications, as they're called. Although Microsoft invented C#, the language and its runtime are documented by the standards body ECMA, enabling anyone to implement C#. Although there are many ways you can use C#, other languages are always an option. Why might you choose C# over these? It will depend on what you need to do, and what you like and dislike in a programming language. Much of C# power comes from the range of programming techniques it supports. For example, it offers object-oriented features, generics, and functional programming. It supports both dynamic and static typing. It provides powerful list and set-oriented features thanks to LINQ. The most recent version of the language adds intrinsic support for asynchronous programming. Some of the most important benefits of using C# come from its runtime, which provides services such as security sandboxing, runtime type checking, exception handling, thread management, and perhaps its most important feature, automated memory management. The runtime provides a garbage collector that frees developers from much of the work associated with recovering memory that the program is no longer using. The .NET framework encompasses both the runtime and the libraries that C# programs use on Windows. The runtime part is called the Common Language Runtime, usually abbreviated to CLR, because it supports not just C#, but any .NET language. The CLR has a common type system, CTS, enabling code from multiple languages to interoperate freely, which means that .NET libraries can usually be used from any .NET language. Fsharp can consume libraries written in .NET, C# can use Visual Basic libraries, and so on. The .NET framework includes an extensive class library. This library provides wrappers for many features of the underlying operating system, but it also provides a considerable amount of functionality of its own. The libraries built into the framework are not the whole story. Many other frameworks provide their own .NET class libraries. SharePoint has an extensive .NET API. And of course, libraries do not have to be associated with frameworks. However, if you design a new COM component carefully, you can make it straightforward to use directly from C#. Windows 8 introduces a new style of API for writing Metro-style tablet applications, an evolution of COM called WinRT, and unlike interop with older native Windows APIs, using WinRT from C# feels very natural. In summary, with C# we get a strong set of abstractions built into the language, a powerful runtime, and easy access to an enormous amount of library and platform functionality. To understand a language, it's useful to compare it with some alternatives, so it's worth looking at some of the reasons you might choose some other language. Its nearest competitor is arguably Visual Basic, another native .NET language which offers most of the same benefits as C#. C# is part of the C family of languages, and if you are familiar with at least one language from that group, which includes C, C++, Objective-C, Java, and JavaScript. Visual Studio offers another language designed specifically for the .NET framework, called Fsharp. This is a very different language from C# and Visual Basic, and it seems to be aimed mostly at calculation-intensive applications such as engineering, and the more technical areas of finance. It is good for expressing particularly complex computations, so if you're working on applications that spend much more of their time thinking than doing, Fsharp may be for you. If you have a development shop full of Ruby experts, choosing C# for your next web application might not be the most effective use of the available talent. Although C# most superficially obvious feature is its C family syntax, perhaps its most distinctive feature is that it was the first language designed to be a native in the world of the CLR. C# embraces the .NET framework, both the runtime and the libraries, so these dilemmas do not arise. In the scenario just discussed, List has no rival. There is no friction when using .NET libraries because they are built for the same world as C#. That's what compilers usually do, and in fact C# has steadily added its own abstractions. But the first version of C# presented a model that was very closely related to the CLR's own model, and the abstractions it has added since have been designed to fit well with the CLR. This gives C# a distinctive feel from other languages. This means that if you want to understand C#, you need to understand the CLR, and the way in which it runs code. The CLR is Microsoft's implementation of the runtime for .NET languages such as C# and Visual Basic. Other implementations such as Mono do not use the CLR, but they have something equivalent. Key features of the C# language include the following. Component orientation. An excellent way to manage complexity in a program is to subdivide it into several interacting components, some of which can be used in multiple scenarios. C# has been designed to make component building easy and provides component-oriented language constructs such as properties, events, and declarative constructs called attributes. One-stop coding. Everything pertaining to a declaration in C# is localized to the declaration itself, rather than being spread across several source files or several places within a source file. Types do not require additional declarations in separate header or interface definition language, IDL, files. Properties get/set methods are logically grouped, documentation is embedded directly in a declaration, etc. Versioning. C# provides features such as explicit interface implementations, hiding inherited members, and read-only modifiers, which help new versions of a component work with older components that depend on it. Type safety and a unified type system. C# is type-safe, which ensures that a variable can be accessed only through the type associated with that variable. This encapsulation encourages good programming design and eliminates potential bugs or security breaches by making it impossible for one variable to inadvertently or maliciously overwrite another. Automatic and manual memory management. C# relies on a runtime that performs automatic memory management. This frees programmers from disposing objects, which eliminates problems such as dangling pointers, memory leaks, and coping with circular references. However, C# does not eliminate pointers, it merely makes them unnecessary for most programming tasks. Leveraging of the CLR. A big advantage of C# over other languages, particularly traditionally compiled languages such as C++, is its close fit with the .NET CLR. Many aspects of C# alias the CLR, especially its type system, memory management model, and exception handling mechanism. For years, the most common way for a compiler to work was to process source code, and to produce output in a form that could be executed directly by the computer's CPU. Compilers would produce machine code, a series of instructions in whatever binary format was required by the kind of CPU the computer had. Many compilers still work this way, but the C# compiler does not. Instead, it uses a model called managed code. With managed code, the runtime generates the machine code that the CPU executes, not the compiler. This enables the runtime to provide services that are hard or even impossible to provide under the more traditional model. The compiler produces an intermediate form of binary code, the intermediate language, IL, and the runtime provides the executable binary at runtime. You can write a .NET component that can run on the 32-bit x86 architecture that PCs have used for decades, but which will also work well in the newer 64-bit update to that design, x64, and also on completely different architectures such as ARM and Itanium. The exact moment at which the CLR generates executable machine code can vary. Typically it uses an approach called just-in-time, JIT, compilation, in which each individual function is compiled at runtime, the first time it runs. Processor-independent JIT compilation is not the main benefit offered by managed code. The greatest payoff is the set of services the runtime provides. One of the most important of these is memory management. The runtime provides a garbage collector, a service that automatically frees memory that is no longer in use. This means that in most cases, you do not need to write code that explicitly returns memory to the operating system once you have finished using it. Although C# close connection with the runtime is one of its main defining features, it's not the only one. Visual Basic has a similar connection with the CLR, but C# is distinguished from Visual Basic by more than just syntax, it has a somewhat different philosophy. Runtime interactivity, programs can richly interact with each other at runtime through their metadata. A program can search for new types at runtime, then instantiate and invoke methods on those types. Portability, programs can be run without recompiling on any operating system and processor combination that supports the CLR. A key element of this platform independence is the runtime's JIT, just-in-time, compiler, which compiles the MSIL code it is fed to native code that runs on the underlying platform. Security considerations permeate the design of the .NET framework. The key to making this possible is CLR's ability to analyze MSIL instructions as being safe or unsafe. Simplified deployment. An assembly is a completely self-describing package that contains all the metadata and MSIL of a program. Deployment can be as easy as copying the assembly to the client computer. Versioning. An assembly can function properly with new versions of assemblies it depends on without recompilation. Key to making this possible is the ability to resolve all type references though metadata. Simplified development. The CLR provides many features that greatly simplify development, including services such as garbage collection, exception handling, debugging, and profiling. Cross-language integration. The Common Type System, CTS, of the CLR defines the types that can be expressed in metadata and MSIL and the possible operations that can be performed on those types. The CTS is broad enough to support many different languages including Microsoft languages, such as C#, VB.NET, and Visual C++.NET, and such third-party languages as COBOL, Eiffel, Haskell, Mercury, ML, Oberon, Python, Smalltalk, and Scheme. Interoperability with legacy code. The CLR provides interoperation with the vast base of existing software written in COM and C.NET. Types can be exposed as COM types, and COM types can be imported as .NET types. In addition, the CLR provides pinvoke, which is a mechanism that enables C functions, structs, and callbacks to be easily used from within in a .NET program. C# favors general-purpose language features over specialized ones. Over the years, Microsoft has expanded C# several times, and the language's designers always have specific scenarios in mind for new features. However, they have always tried hard to ensure that each new element they add is useful beyond just the scenario for which it was designed. One of the goals for C# 3.0 was that database access should feel well integrated with the language. The resulting technology, Language Integrated Query, LINQ, certainly supports that goal, but Microsoft achieved this without adding any direct support for data access to the language. Version 3.0 of C# made it very much easier to process lists, sets, and other groups of objects, because the new features work for collections of things from any origin, not just databases. Perhaps the clearest illustration of this philosophy of generality was a language feature that C# chose not to implement, but which Visual Basic did. In VB, you can write XML directly in your source code, embedding expressions to calculate values for certain bits of content at runtime. This compiles into code that generates the completed XML at runtime. VB also has intrinsic support for queries that extract data from XML documents. These same concepts were considered for C#. As for querying XML documents, C# supports this through its general-purpose LINQ features, and does not add any XML-specific support. XML* has waned since this language concept was mooted, having been usurped in many cases by JSON. The most significant new feature in C# 5.0 is support for asynchronous programming. .NET has always offered asynchronous APIs, i.e., ones that do not wait for the operation they perform to finish before returning. Asynchrony is particularly important with I/O operations, which can take a long time and often don't require any active involvement from the CPU except at the start and end of an operation. The problem with the more efficient and flexible asynchronous APIs has always been that they are considerably harder to use than their synchronous counterparts. But now, if an asynchronous API conforms to a certain pattern, you can write C# code that looks almost as simple as the synchronous alternative would. Although asynchronous support is a rather specialized aspect of C#, it's still fairly adaptable. It can use the Task Parallel Library, TPL, introduced in .NET 4.0, but the same language feature can also work with the new asynchronous mechanisms that Windows 8 uses in WinRT, the API for writing Metro applications. Visual Studio is Microsoft's development environment. There are various editions ranging from free to eye-wateringly expensive. All versions provide the basic features such as a text editor, build tools, and a debugger, as well as providing visual editing tools for user interfaces. It's not strictly necessary to use Visual Studio. The .NET build system that it uses is available from the command line, so you could use any text editor. But it is the development environment that most C# developers use, so I'll start with a quick introduction to working in Visual Studio. C# was initially created specifically for use with the .NET platform. C# is used with the .NET framework, which allows you access to a number of libraries that are specifically intended for use with Windows. The Common Language Runtime, CLR, is the component of the .NET framework that allows you to compile and execute applications written in either C# or Visual Basic .NET. C# is designed to be simple, type-safe, object-oriented, and high-performance. C# applications consist of human-readable source code, written in a text editor. The source code is compiled into Microsoft Intermediate Language, MSIL, which, at runtime, is compiled into machine code. A namespace is a way of grouping the names that you assign to elements in your application so that they don't conflict with other names, either yours or those assigned by Microsoft or other developers. Classes are the core building blocks of C# and object-oriented programming because they allow you to create new types that model types in the problem domain, that is, that model things in the area you are concerned with. A method is a named block of code that performs an action and that may return a value. A comment is a note for the programmer and does not affect the running of the application. A string is a set of text characters enclosed in quotes. You can use C# to develop console applications, Windows applications, web applications, and web services. Now, let's open your web browser and go to Google search, type Visual Studio 2013. Let's download and install it. Let's open Visual Studio. Thank you for watching this video.